We look at another number challenges for 2023, that is a math problem with number 2023. Now here m and n are different numbers, and 2023 raised to m and n's power have the same last 3 digits. Now we need to find the minimum value of m plus n. Pause the video and try to find the answer. We look at this problem here. So we need to find the minimum value of m and n so that these two numbers have the same last 3 digits. One thing we can do is that we only need to focus on number 23. Why? Because 2023, that is 2000 plus 23. If you raise to an integer power, we use binomial theorem, that is a plus b's power, a bunch of 2000 here, multiple, and the final term of binomial theorem will give you 2023 to the nth power. Every other term here has a factor of 2000. So for last 3 digits, what matters is only this part. We can revisit the original problem. We need to find m and n different number such that now these are the same. The 23 raised to m, 23 raised to n have the same last 3 digits. So one important property is that for any integer, if you raise to the powers the last single digit or 2 digit or 3 digits have a property that it's going to repeat. So there's going to be a cycle. Now we need to find out the cycle. So we use a Python program here, try to find out how this pattern is going to repeat. What we do here is, let's say try up to 2000, and then we're going to remember the powers, and then we're going to check for repeat. If we find the value in the list, we know that that is where a cycle starts. All right, so let's run that, and then the number here is 100. 23 raised to 0th power, which is 1, versus 23 raised to 100th power, modulus 1000 is 1. From the Python program, we know that the powers of 23 modulus 1000 begin to repeat after every 100th power. So in that case, the last digit is going to repeat, and then since m and n are positive integers, so the minimum value you can take for m plus n is n equal to 1, and then m equal 101. All right, the total is 102. That's the answer to the original problem. We solve the problem by examining the cyclic pattern of 23 raised to the nth power. There is an important concept in number theory, that is the order of integer a modulus n. In other words, we try to find the minimum integer k such that a raised to the kth power congruent to 1 modulus n. Now in our case, we need to find out what is 23's order modulus 1000. Now we use a Python program to find that. That's 100. But then there is an important theorem, that is Euler's torsion function. But what it says is that if the GCD of a and n here is 1000, a is 23, they're indeed relatively prime, then a raised to this phi function here is going to be congruent to 1. In our case, phi 1000 have this property. Now, while the order of number, for example, 23 modulus 1000, is not the main topic today. However, that is an important concept in elementary number theory. We're going to cover that in the future videos. So for that, please like, share, and subscribe to the channel. We're going to cover some interesting problems in number theory and other subjects.